Assalamu alaikum students. Okay, we now will discuss another different type of condensation reaction which is called Erlenmeyer Azlactone synthesis. So actually you have studied the Perkin condensation reaction. This is the application of Perkin condensation reaction. You have remembered that in Perkin reaction we treat acetic anhydride with benzaldehyde to give elongate the acetic chain. So we will get the alpha beta unsaturated carboxylic acid. So it is the application of the Perkin condensation reaction which will be used for the synthesis of alpha amino acids. You know what are the alpha amino acids? So this is used for the synthesis of alpha amino acids. So in this Erlenmeyer Azlactone synthesis, what happens that acyl glycine, any acyl glycine, you know the glycine formula. The glycine is an amino acid, and this will be the formula of glycine, like this one. This is the formula of glycine. You know that any amino acid must have an amino and carboxylic group. So this is the glycine which has the amino and carboxylic acid. So when you treat any acyl glycine means any glycine which has this group, COR group. So when you have a COR group to any glycine, it is called acyl glycine. So in this section, any acyl glycine, you can use any R group here. So COR group is treated with N, it is called the glycine, acyl glycine. So the any acyl glycine is condensed with aromatic aldehyde in the presence of acetic anhydride sodium acetate to get the product. This type of condensation is called Erlenmeyer Azlactone synthesis. So what is Erlenmeyer Azlactone synthesis? In this synthesis, you treat the acyl glycine with an aromatic aldehyde having no alpha hydrogen in the presence of acetic anhydride and sodium acetate. So it has different steps. It is a long process. So first we will discuss the first process. In first step, what happens that glycine is converted into azlactone by the dehydration of its inert tautomer with acetic anhydride. I can explain. So you have this type of glycine. In this glycine, the benzoyl group is attached. BENZOYL. Benzoyl group. This benzoyl group. This type is called benzoyl. This benzoyl group is attached with the glycine. So it is called benzoyl glycine. So what happens? The benzoyl glycine exists in two types of tautomers. One is this tautomer in which NH and CO are present. Another tautomer, what happens is H from here moves to oxygen and double bond to oxygen moves to here. So it is called the enol form of this one. This is the keto form of this benzoyl glycine. So what happens that is enol form of benzoyl glycine when treated with acetic anhydride, this will give you a ring. I will give you the mechanism at the end. So this will give you the ring. This ring is called azlactone. Azlactone. Why it is called azlactone? Because lactone is a compound which contains cyclic ester. All those esters which are cyclic, they are called lactones. So this is a cyclic ester, you can see. But here we also have an Az group. As you know, the nitrogen is called Az group. So it is an azlactone. So first of all, what happens? We convert glycine into benzoyl glycine by attaching a PHCO group to this one. This has a enol tautomer. This enol tautomer in the presence of acetic anhydride will react in the same mechanism as we have given in the Perkin condensation. So you will get a ring which has a 5-member ring in which we have an ester group. So it is a cyclic ester having nitrogen. So it is called azlactone. Now we will see the second step in next. Okay, now we move to the second step. What happens in the second step? The azlactone that we have made react with any benzaldehyde in the presence of acetic anhydride, and actually this is the step of the Perkin condensation, and we will get this compound. What happens that this carbon, alpha carbon, which is catalyzed by this carboxylic group, is activated. This carbon is activated methylene. So acetic acid will remove the proton from here. The negative anion is formed, and negative carbon ion will attack on this carbonyl group, and as a result OH is formed, and then OH and hydrogen from here removed, and you will get alpha beta unsaturated compound. Now this compound will again is hydrolyzed. So in the third step, this compound which was formed is treated with phosphorescent hydrogen iodide, actually it is a step of reduction. So reduction of this double bond takes place, so you will get a single bond. Now when it is hydrolyzed, then this bond opens, you will get here OH and here OH. This bond is broken, you will have H here and you will have H here, so you will have two hydroxyl groups, the ring will be opened, and then this one is inward form, this tautomer form is formed, and this tautomer form is when hydrolyzed, so this bond is removed, the benzoyl group is removed, and you will get another alpha amino acid. You have remembered that we have started with glycine, which has only one carbon to which the NH and COH was attached. Now at the end we have another PHCH2 group is attached with this glycine, so it is another alpha amino acid is formed. In this way you can synthesize a lot of amino acids by using this Erlenmeyer Azlactone synthesis.